Mastery of Music Theory, Book 1, Fundamental Materials, by Brian Kehlenbach. The word rhythm derives from the Latin rhythmus, which means movement in time, and also the Greek rhythmos, which means measured flow. In music, the term rhythm refers to how we describe and notate the way that the music is organized in time. The most basic element of rhythm is the beat, the basic pulse of the music. Music beats follow certain stress patterns that can be perceived by differing levels of accentuation in the forward flow of the notes. This is much like poetry, in that most poems present words with stress patterns that serve to organize the flow of the word diction in time. Examine this excerpt from the poem The Robin by Thomas Hardy. When up aloft I fly and fly, I see in pools the shining sky, and a happy bird am I. When I descend towards their brink, I stand and look and stoop and drink, and bathe my wings and chink and prink. Adding a bit more weight or accentuation to the words or syllables that are underlined, here we seem to get a rather pleasing flowing of the verses that matches the implied natural inflection of the words. Notice that there are two such accentuations on each line of poetry. Poets, of course, adopt their own vocabulary for describing these patterns. The accentuated units are called feet, and the pattern of 2 feet per line is called dimeter. If we were to hear music with a similar stress pattern, we would label the stressed components as the beats, and employ the musical term duple-meter to describe the consistent groupings of 2 beats in the rhythm. Here's another example, A Psalm of Life by Henry Wadsworth Longfellow. Tell me not in mournful numbers, life is but an empty dream, for the soul is dead that slumbers, and things are not what they seem. In this excerpt, the poem seems to be organized with 4 accentuations per line. The poet calls this tetrameter, but the musician would call a similar situation in music with consistent 4 beat groupings quadruple meter. Quadruple meter is one of the most common meters in music, and musicians often use the term common time when describing it. Where the poet placed words on individual lines to delineate the meter, the musician places groupings of notes within measures that are bound by measure lines. This example contains 4 measures, and each measure contains 4 beats. Any meter with 4 beats per measure is called quadruple meter. To practice this rhythm, you should turn on a metronome, set it to a reasonable speed, perhaps 60 beats per minute, then go ahead and clap the beats in a steady time. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. In order to provide notation with rhythmic precision, there are several note values we must learn to write, recognize, and perform. The first is the quarter note, which we will substitute for each of the slash marks used in the other example we looked at. The quarter note consists of 2 parts, the filled-in note head and the vertical line protruding from the note head that is called the stem. Notice the first measure of this example starts with what appears to be a fraction. This 4/4 marking is a time signature that explains the meter of the music to the musician so that the notes can be properly interpreted. The musician calls this 4/4 time, but when interpreting time signatures, it may be easier to think of it like a fraction. In other words, 4/4 means there are 4 fourths in each measure. The top number 4 referring to the number of beats per measure, and the lower 4th referring to the quarter notes that represent the beats. Once we know that the meter of the music is 4/4, we can construct a chart that describes the note values of the various rhythmic note symbols. Keep in mind that the relative rhythmic values of the various notes will always be the same, but that the specific beat value of any particular note will change for different time signatures. For example, the quarter note gets 1 beat in the chart here because the lower number in the 4/4 time signature is 4. And it is this number that assigns the value of 1 beat to the quarter note. We'll discuss this further in a subsequent chapter. Note how the chart is constructed. In the center of the chart are the quarter notes representing the beat level. This is called the beat level because in 4/4 time the beat is represented by quarter notes. Above the quarter notes are the half notes, each half note comprising the same amount of time as 2 quarter notes. As you can see, the half note has an open note head and a stem. And still above the half notes, we have the whole note, each whole note comprising 2 half notes or 4 quarter notes. The whole note is just an open note head. Beneath the quarter note level, we have the eighth note or division level. It is so called because eighth notes move twice as fast as quarter notes, in essence, dividing them in half. As you can see, eighth notes have a note head, a stem, and 1 flag that flies to the right of the stem. Beneath the eighth notes, and twice as fast, are the 16th notes at the subdivision level. The 16th notes, with 2 flags flying to the right of the stem, further subdivide the beat values. Regardless of how eighth notes and 16th notes are positioned in music, the flags always fly to the right of the stem. Now this example shows the same note values and relationships but with a different appearance for the 8th and 16th notes. The stems have been replaced with beams. Beams are heavy, straight lines that connect with the stems to organize the notes into beat groupings. In other words, a beam can group 2 eighth notes together because 2 eighth notes comprise 1 beat in 4/4 time. Sometimes you will see groupings of 4 eighth notes in 4/4 time, as this also presents a clear visual pattern to the performer. Likewise, beams can group 4 16th notes together because 4 16th notes comprise 1 beat in 4/4 time. Whenever possible, the musician would rather see beams on the musical page for ease of reading, but it will be necessary to have both ways of notating these values for rhythmic clarity. Once we know the meter and values of the notes, we can construct a multitude of different combinations to produce interesting rhythms, as shown here. In this example, the notes were written in the G clef, while the pitch is on A4. Notice the double bar at the end of the excerpt. This is the proper designation for indicating the final bar line of a piece of music. The fractions written below the notes in this example are not indicating the name of the note values. Instead, they are showing the number of beats or the fractional part of a beat each note has in 4/4 time. This way you can easily see that each measure has 4 beats by adding all the numbers of each measure. While this may seem somewhat helpful in coming to an understanding of the note values and how they fit in the measures, it is actually a very awkward way to label the notes if we wish to perform the rhythm. A preferable way would be to adopt a standard counting method, and then employ it consistently throughout every measure. In this way, we can actually count out loud while clapping the rhythm. Counting methods can be applied to the beat level. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. The division level. 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and. Or the subdivision level of the rhythm. 1E and a 2E and a 3E and a 4E and a 1E and a 2E and a 3E and a 4E and a 1E and a 2E and a 3E and a 4E and a. Clap the following 3 examples and count out loud using the counting method printed below the notes as you perform. In the top example, the fastest moving note is the quarter note. Therefore, beat level counting was applied throughout. Note that the counts beneath each measure are exactly the same, and that they line up clearly to show the number of beats in each note value. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. In the middle example, the eighth note is the fastest moving note. Therefore, division level counting was applied consistently in every measure. Each of the counts in division level counting, 1 and 2 and 3 and 4 and, represents an eighth note in 4/4 time, and these are accurately aligned below each note value to indicate how the rhythm lines up to the eighth notes. 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and. In the bottom example, the 16th note is the fastest moving note, and subdivision counting has been applied in every measure. In subdivision counting, each of the counts, 1E and a, 2E and a, 3E and a, 4E and a, represents a 16th note in 4/4 time, and these are aligned below the note values to indicate how the rhythm lines up to 16th notes. 1E and a, 2E and a, 3E and a, 4E and a, 1E and a, 2E and a, 3E and a, 4E and a, 1E and a, 2E and a, 3E and a, 4E and a. By counting rhythms this way, you will acquire a very precise sense for how to perform rhythms accurately and consistently. To extend a note value, we sometimes tie 2 or more notes together. To employ a tie, always draw it from one note head to the next note head, as you can see. The musician interprets this tie by holding the note for its full composite value without re-articulating it. 2 rhythmic examples with ties are given here. When clapping the rhythms, keep your hands together for the entire duration of the tied notes. Brackets have been placed under the tied notes, as well as the longer valued notes, to make it clear when your hands should stay together as you count. Example A. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Example B. 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and. Notice in the bottom example, the beams were used in a unique way on beat 2 of the first measure and beat 3 of the second measure to show both 16th notes and an 8th note in a single unit. We will see many more similar configurations of beams. Example C. 1E and a, 2E and a, 3E and a, 4E and a, 1E and a, 2E and a, 3E and a, 4E and a, 1E and a, 2E and a, 3E and a, 4E and a. Another way to extend the value of a note is to add a dot immediately to the right. Precisely, the dot adds another 50% to the value of the note, making the entire rhythmic value 150% of the original. Employing a dot is the same as tying a note to another note value that is only half as long. For example, the dotted note is worth 3 beats in 4/4 time, or 150% of the 2-beat value of the half note without the dot. This is the same as tying the half note to a quarter note, as shown here. Here are some other common dotted notes. The dotted whole note, the dotted quarter note, the dotted 8th note. In these rhythmic examples, brackets are drawn only under the dotted notes for you to see how the various counting methods work with dotted notes. Clap these rhythms while counting out loud. Example A. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Example B. 1 and 2 and 3 and 4 and 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 1 and 2 and 3 and 4 and. Example C. 1E and 2E and 3E and 4E and 1E and 2E and 3E and 4E and 1E and 2E and 3E and 4E and. There are a few careful observations that you should make in this example regarding the use of dotted notes. Firstly, the counting of the dotted notes seems rather consistent, with 3 separate counts comprising each occurrence. For example, the dotted half note in the first example, we use the counts 1, 2, 3. Or, as seen in measure 2, 2, 3, 4. In the middle example, the dotted quarters use count combinations of 3 also, as in 1 and 2, or and 2 and. The bottom example presents the dotted 16th notes in 3 count combinations, as in 1 E and, or E and a. This example illustrates an important notational rule that requires rhythms in 4/4 time to be written so that the middle of the measure is easily seen, especially when there are note values at the division level. For example, in measure 1 of this example, the rhythm is written so that we can easily draw a line down the center with a 1 and 2 end on the left side and the 3 and 4 end on the right. The notation of this example is a poorly placed dotted note. You can see that it is impossible to draw a line down the center of the measure without it cutting through the center of the dotted note. The notation used to the right has the exact same sound as that to the left, but the rhythm is notated as a tie instead of as a dotted note, and this allows us to see clearly the middle of the measure. This is much preferable, as it is easier for the musician to sight read a measure where the center is clearly visible. In this example, both the notation to the left and the notation to the right sound exactly the same. But in the notation to the left, there is little regard for the beat organization. A musician would become very upset if handed music like this to play. In contrast, the example to the right shows correct usage of the beams in a way that carefully organizes the rhythm into beat units. Now, up to this point, we have been examining quadruple rhythm, written in 4/4 time, also known as common time. But there are several other meters that utilize the relative rhythmic values in a similar way. In fact, any time signature with a 4 as the bottom number will use quarter notes to designate the beat level. This includes 3/4 time, triple meter, 2/4 time, duple meter, and 5/4 time, quintuple meter. Some examples are shown here. Remember, it is the top number of the time signature that tells us how many beats in the measure, and the bottom number that tells us which type of note gets the beat. You should clap each example while counting aloud. A. 1 and 2 and 1 and 2 and 1 and 2 and 1 and 2 and 1 and 2 and. B. 1 and 2 and 3 and 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 1 and 2 and 3 and. C. 1E and 2E and 3E and 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 1E and 2E and 3E and. D. 1 and 2 and 3 and 4 and 5 and 1 and 2 and 3 and 4 and 5 and 1 and 2 3, and 4, and 5, and. Now in music, the instances of silence are at least as important as the instances of sound. And to notate these silences, we use rests. For every rhythmic note value shown, there is an equivalent rest value. Except for one case, the relationship among the rest values are fixed, as shown in this chart. The whole rest is an exception. Its value is different from any other rhythmic value in music, in that it varies depending on the top number of the time signature. A whole rest is used to indicate rest for an entire measure, regardless of the number of beats in a measure. The notation of the whole rest and examples in various time signatures are shown here. Now, just as with note values, we can add dots to rests to extend their value, but this is rarely done in the time signatures we have studied so far, except for the dotted eighth rest. Unlike note values, we would never use ties to connect rests, as this is unnecessary. The placement of rests is rather particular, and we should take care to employ them in a clear fashion. For example, half rests are usually reserved for 4/4 time to occupy either the first two beats, 1, 2, or the last two beats, 3, 4. We would never see a half rest in the middle two beats, 2, 3. And we would never use the half rest in 3/4 time. In those instances, quarter rests would be used for clarity. Quarter rests always start on a beat, never on the second eighth note of a beat. An eighth rest always starts on the first half of a beat or on the second half of a beat, never on the second or fourth 16th note of a beat. And just as with notes, it is always best to make sure the beat units, as well as the middle of the measure in 4/4 time, are very clear whenever practical and possible. Rest should never obscure the beats or the center of the measure in 4/4 time, unless it is extremely clear, as in the case of a whole rest.